Hello everyone. I just wanted to go over balancing equations with you. I know I've posted some videos for practice, but we're coming up on a quiz, so I wanted to go over a few examples. Now I've taken the examples from the notes PowerPoint that I posted day 16. I've posted the whole PowerPoint, and so I'm going to go over slide 10. I'm going to pick out some of these. So the first one is this. And so you have silver nitrate. You need a review on your balancing compounds and writing, naming and writing formulas. But on these, what I'm going to do is I'm just going to stick to balancing for this quiz. So I will give you this equation, and all you have to do is put in the coefficients. The coefficients are the numbers that go in front of each compound, and they multiply everything in there. The one thing to remember is look at your polyatomics. Your polyatomics usually they're not going to change, and if they do, then you'll look at the elements only. But here what I'm looking at is I have one nitrate, and then I look over here and I have two nitrates at the end of the equation. Well, if I end up with two, and I have to have two because this compound is written correctly, the formula is correct, I can't change it. I can't just erase that two. So what I'm going to do is make sure that I have two nitrates on this side. But if I put a parentheses a 2 or stick a 2 here, it's going to change the formula. Cannot do that. Never change your formulas. So what I'm going to do is I'm going to make sure I have 2 on this side. So I'm going to put a large 2 in front of that compound. That means it is going to multiply both the silver and the nitrate. So I have 2 silvers and I also have 2 nitrates. Now you can do each element individually, but it takes a lot more time and I think it's more complicated. So 2 nitrates, and I have 2 nitrates. Does it really matter which element I start with? No. As long as the end result, you have the same number of atoms on both sides. Okay, so now what I've done is, in order to get the nitrates to balance, I've changed the silvers. So now I have to go and change the silvers. So I have 2 silvers on this side, and I have only 1 over here. So what I'm going to do is put a large 2 in front of that. So I have a coefficient of 2 for my silver. So now my silver is balanced. The nitrates balance. What about the copper? Well, I have 1 on this side, I have 1 on this side. So I'm done. Okay, check. All right. Okay, for our next part, what we're going to do is take a look at these equations, which I've taken again from the same PowerPoint notes, but now I'm going to go to slide 14. If you have your notes, you can get those out. You can, have printed them off, or if you just want to look. Okay, so let's pick some of these. So I've picked this one, which is, I've got, let's see, 1 H here. Do I have any other H's? Yes. Now this H is part of a polyatomic ion. Okay, so do I have the same polyatomic ion on the other side? Well, kind of. So you can either do this by elements or water. You can split it up into HOH. Let's do it both ways. So what you can do is say water is H2O, but if you split it up into those ions, it's a little easier to balance. So let's take this. I've got 1 OH, and over here I have 1 OH. I have 1 H, 1 H. I have 1 Na, 1 Na, 1 Cl, 1 Cl. So it is balanced. Now, if you don't want to do that, and you want to not look at that as polyatomic, now let's just do the elements. Okay, so I have 2 H's, 1, 2. So I'm going to ignore that as a polyatomic. 1, 2, 2 H's. 1 Cl, 1 Cl, 1 sodium, 1 sodium, 1 oxygen, 1 oxygen, and that is already balanced. Your coefficients in this case would be 1, 1, 1, 1. Don't put 0, because if you put 0, that means you have to get rid of it, and we still have it. All right, let's try this one. Now, this is a combustion reaction. So I have some kind of a compound that it's going to burn in oxygen, and usually I'm going to have some heat with it, which I put a little delta sign. So let's take a look at what I have on either side. What I would recommend is if you see CO2 and water, I want you to do oxygen and hydrogen last. That's just a recommendation. Okay, so if I can't do oxygen or hydrogen, let's try carbons. Okay, so let's try carbons. I have 2 carbons here. I have 1 here because that 2 only goes to the oxygen. That means I need to put a coefficient of 2. 2 carbons, 2 carbons. Now I have to go into hydrogen and oxygen. So let's try hydrogen before I do oxygen. Just tends to be a little easier. All right, let's add up the hydrogens on this side of the equation. I have 5 here and 1 here. That makes 6. Okay, so that means I need 6 on this side. So I need to put a number that will multiply 2 to make 6. So that would be a 3. All right, so 3 times 2 makes 6, and I have 6 on this side. All right, now let's go to our last element, make sure it's balanced, which is your oxygen. 1 oxygen here. I have 4 oxygens on this side, plus 3. So 4 plus 3 equals 7. All right, so I need to make 7 on this side. Well, if I put a 2 here, that's 4. Let's see if I put a 3 here. That would be 6, but I have 1 oxygen here. So that makes 7. I have 7 on this side, and we're done. The last one, okay, let's see. We've got this reacting with water to form phosphoric acid. Okay, let's count them. Does it really matter on this one, which I start with? No. Combustion reactions, I would suggest doing hydrogen, then oxygen, but after you've done anything else. All right, so let's take 2 P's and 1 P. Now, I have a polyatomic ion here, but I don't have it on this side. So I'm not going to do polyatomics like I did for these. So let's just take the elements. 2 phosphorus, I need to have 2 here. Cannot change the formula, so I put a 2 in front. So this multiplies everything. So I'd have 6 hydrogens, 2 phosphorus, 8 oxygens. Okay, I've done P. Let's continue something else. Usually if you kind of get stuck, leave oxygen till last. So let's try hydrogen now. All right, I've got 2 times 3 makes 6 hydrogens. On this side, I have 2. Can I put a number here that will make 6? Yes. 3 times 2 makes 6. 2 times 3 makes 6. I'm good. All right, let's try the oxygens. I have 5 on this side, and I have 3. So that makes 8. 8 oxygens. Do I have 8 on that side? This 2 is going to multiply the 4, and that makes 8. So we're done. So I've tried to pick some of the harder ones to balance, some with some tips to help you. I hope this helps, and you can always contact me. Look back on the videos. I put Tyler DeWitt's really good. If you see any of his videos, he's a really good tutorial. All right, I'll see you later. Hope this helps. Bye.